You know, it's kind of funny. We can peer billions of kilometers into the cosmos, but what's right under our own feet? It's a total mystery. The center of our own planet is one of the most out-of-reach places you can imagine. So, how in the world did we manage to get a picture of it? How did we basically X-ray the Earth to see what's inside?
Okay, so to really get a handle on just how big this challenge is, let's start with humanity's best shot at actually digging down. And I'm not talking about some futuristic sci fi vehicle. Nope, we're talking about a good old fashioned but absolutely enormous drill bit.
So back in 1970, the Soviet Union started this insane project. They drilled what is still the deepest artificial hole on Earth. It's called the Kola Super Deep Borehole. And get this, it took them more than 20 years to get that far. Just a monumental feat of engineering. And this is where the scale of the problem really hits you. 12 kilometers? That sounds crazy deep, right? But when you compare it to the Earth's total radius, over 6,000 kilometers, it's well, it's nothing. It's barely a scratch. It's like trying to figure out what's inside an entire apple by just piercing the skin. So that's the big question, isn't it? If we can't physically get there, if we can't even really get past the crust, how do we know anything about the mantle, let alone the core? How can we map out the inside of our planet with so much confidence? Well, the answer, believe it or not, didn't come from digging. It came from listening. Scientists realized that nature itself was providing the perfect tool to probe the Earth's depths, completely for free. Think about this. Every single day, there are about 55 earthquakes happening somewhere on the planet. And each one sends these super powerful vibrations, seismic waves, rippling out from the source, traveling through the entire planet, and carrying vital clues about everything they pass through. The best way to think about it is like a medical ultrasound. You know, a doctor uses sound waves to see inside a body without ever making a cut. Well, seismologists do the exact same thing, just on a planetary scale. They use the sound of earthquakes to see inside the Earth without ever having to drill. All right, so to crack this planetary case, these seismic detectives focused on two main types of waves. These became their key pieces of evidence. First up, you've got P waves, or primary waves. They're the speed demons, the first to arrive at any detection station. They push and pull the rock as they move, kind of like a slinky, compressing and expanding. And here's the crucial part. They can power through any state of matter, solid, liquid, or gas. Following right behind them are the S waves, or secondary waves. They're a bit slower, and they move the ground up and down or side to side, kind of like shaking a rope. But, and this is the huge but, they have one critical weakness. They are completely stopped by liquids. They just cannot pass through them. Look at that, right there in the bottom right corner. That one simple fact, that S waves cannot travel through liquids, is the single most important clue we have about the center of our planet. It is the master key. So whenever an earthquake happens, seismograph stations all over the world are listening for these P and S waves to arrive. But as they collected more and more data, they noticed something really strange. A huge part of the world was just silent. The P waves would show up almost everywhere. Sure, they'd bend a little as they passed through different layers, creating a small shadow. But the S waves? Whoa. There was a massive shadow zone covering nearly half the planet where they were never detected at all. They just vanished. And remember what we just said about S waves. They can't travel through liquid. So if they disappear every single time they try to cross through the center of the Earth, well, the conclusion is pretty inescapable. This S-wave shadow zone was the definitive evidence. It was the smoking gun. It proved that at the heart of our planet lies a gigantic sphere of molten, liquid metal, what we now call the outer core. We had X-rayed the Earth. This one discovery allowed scientists to finally assemble the full picture. It revealed that our planet is structured kind of like an onion, with all these distinct layers that were defined by how those seismic waves traveled through them. So here it is, the complete picture. We've got the thin crust we live on, then the vast, mostly solid mantle. Below that, you've got that liquid outer core. And the constant churning of that liquid metal is what generates our planet's protective magnetic field, which is awesome because it shields us from all that harmful solar radiation. And right at the very center, the P-wave data revealed one final twist. A solid inner core, squeezed into a solid state by unimaginable pressure, even though it's literally hotter than the surface of the sun. Now that we've mapped the whole interior, let's just have a little fun. What if we could actually make the journey? What if we could just ignore the impossible heat and pressure and just fall right through?
Imagine a frictionless, vacuum-sealed tunnel running straight from one side of the Earth to the other. You put on a heat-proof suit, you step up to the edge, and you take the leap. How long would that trip actually take? You'd accelerate constantly, pulled by gravity faster and faster towards the center. You wouldn't actually hit 0 G until you reach the exact middle of the planet. That first half of the journey, just 19 minutes.
Right as you pass that inner core, you would hit your top speed, a blistering 40,000 kilometers per hour, all without a single drop of fuel.
After passing the center, gravity would start pulling you back, slowing you down perfectly. You'd pop out on the other side of the planet exactly 38 minutes after you jumped in.
It just goes to show you, sometimes the greatest frontiers aren't way out in space, but right here, under our feet. By learning to listen to the subtle vibrations of our own world, we were able to see the impossible. It really makes you wonder, doesn't it? What else are we missing, just waiting for the right way to look?